Welcome to this class. In this short video, we're going to derive the equation of a vertical ellipse whose origin is at the whose center is at the origin. So derivation of equation of an ellipse whose center is at origin, major axis, along the y-axis. So please, if you have not watched the derivation of the equation when the major axis along the x-axis, please watch it before you watch this. So we draw the axis. So this is the x, this is the y, this is O, and then let this be the ellipse. And on this ellipse, this is our center, the origin. Let this be one of the focus. This be the focus. And then this be the vertex. This be the vertex. So these are the ends of the core vertices. And let's label our diagram. This one to be V1. This one to be F1. This one is our center. This one to be F2. This one to be V2. This one to be V1. This one to be V2. So we said customarily the distance from the center to the foci, each of the foci is C units, and distance from the center to the vertices is A units. So the coordinates of this one will be 0, A, and this other one will be 0, -A. And the coordinates of this one will be 0, C, and this other one will be 0, -C. So therefore, let's identify a general point P on the ellipse, assuming that that P is here. Can draw it at any point you like, and then join that P to the two foci. So this distance, and then join it to this point, so that now this is P, which has general points X, Y. And then from the definition of an ellipse, we say that ellipse is the set of all points in the plane such that the sum of the distance from every point on the curve to two fixed points called foci are constant. And in the previous case, we saw how we find the value of the constant as 2a. So distance from P to F2 plus distance from P to F1 must give us a constant. This is by definition of what an ellipse is. And coordinates of P are given by X, Y, coordinates of F2, we have 0, minus c. Coordinates of F1 are given by 0, c. And this constant in the formula, we have found out that is given by 2a. So using distance formula for distance between 2 points in a plane, we have, so the distance from P to F2 will be given by square root x minus 0 squared plus y minus c, so y plus c squared, square root x minus 0 squared plus y minus c squared that should give us the constant, which is 2a. And then we simplify this equation by taking one of the root terms to the right. So we say square root of x squared plus y plus c squared equals to 2a minus square root x squared plus y minus c squared. So we have, to simplify this one, is square both sides. So squaring both sides, we have, so I mean, you apply square on this side and square on this side. So squaring this one, just move the square root sign. So we'll have x squared plus y plus c squared. Square this one, this first term is 4a squared plus square of this one is just what we have inside the square root sign. And then minus twice this term and this term. So we'll have 4a square root of x squared plus y minus c squared. So remember what I'm using to do this step to get this one here is knowing that a minus b squared is given by a squared plus b squared minus 2ab. So you take your a to be 2a, your b to be square root of this term, this value here. So next step, let's now expand these squares. So we'll have x squared plus y squared plus c squared plus 2cy equals to 4a squared plus x squared plus y squared plus c squared minus 2cy minus 4a square root of x squared plus y minus c squared. So then we cancel like terms. See x squared, y squared, and then c squared. So by doing that, now we have 2cy equals to 4a squared minus 2cy minus 4a square root x squared plus y minus c squared. Take this to the left-hand side. We have 4cy equals to 4a squared minus 4a square root of x squared plus y minus c squared. Then I can divide through by 4, because 4 is common to every term. So I divide through by 4, by 4, by 4. And so therefore this is 1, 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 this is 1. I get cy equals to a squared minus a square root of x squared plus y minus c squared. So I take this to the left hand side and take this one to the right hand side so that I have a square root x squared plus y minus c squared equals to a squared minus cy. So by doing that one, I can now eliminate the square root sign by squaring both sides. So I square this side, and I also square this side. So I'll get a squared into x squared plus y minus c squared equals to a power 4 plus c squared y squared, and then minus 2c a squared y. And then let's open this bracket. So we have a squared into x squared plus y squared plus c squared minus 2cy equals to a power 4 plus c squared y squared minus 2c a squared y. So this is what we have. Now you open the brackets here, a squared x squared plus a squared y squared plus a squared c squared minus 2c a squared y equals to a power 4 plus c squared y squared, and then minus 2c a squared y. This step, you see that this term here and this term here are the same and have the same sign, so they cancel out. So the next step will be a squared x squared plus a squared y squared plus a squared c squared equals to a power 4 plus c squared y squared. Now what you do, you take terms with y's and x's to one side, and then terms without x and y's on the other side. So I mean, take this to the left so that I have a squared x squared plus a squared y squared. Then this will now be negative c squared y squared equals to, now when this one comes to the right hand side, this term will be negative a power 4 minus a squared c squared. Now you see here y squared is common and here a squared is common. So you say a squared x squared plus a squared minus c squared times y squared equals to a squared into a squared minus c squared. And since a is greater than c, then a squared is greater than c squared, and then a squared minus c squared is greater than 0. So it means that this quantity here is positive. That difference a squared minus c squared is positive. So therefore, for us to ensure that what we are fixing for it is a positive value, then we make it a square. So therefore we say let b squared be given by a squared minus c squared. So that means that now this equation will be a squared x squared and then plus b squared y squared equals to a squared b squared. This part is b squared. And since a is greater than c and a is not 0, and also b is not greater than 0, is not 0, then square of a times square of b is a non-zero value, so we can divide by that value. So dividing through, we have a squared b squared, a squared b squared, a squared b squared, so that a squared and a squared cancels out, b squared and b squared cancels out. This is 1, this is 1. So the next step will give us x squared over b squared plus y squared over a squared equals to 1. So we can rearrange it as saying y squared over a squared plus x squared over b squared equals to 1. So this is the equation that we are interested in. Equation of a vertical ellipse centered at the origin. So you say this is the equation of a vertical. So when you say vertical ellipse, we mean that the major axis is vertical. Vertical ellipse centered at origin. So that's what we have. So thank you. And in the next video, we'll now be describing terms or how to find the general coordinates of vertices, foci, and those vertices for this kind of an ellipse and the one that we derived in the first case. So thank you.